Hey guys, welcome to the first video of what's going to be a series on differential equations. This first video is going to be tailored towards just a formal introduction, introduce the topic, get some definitions out the way before we actually move into solving these equations later on. But I'm assuming because you're here, you know what differential equations are, you know the basics, but um, yeah, let's just go over them again in this video. So let's start with this. Let's say I have an equation, a simple equation that says y is equal to 2e to the 2x. Okay, if I was to take the derivative of this, I would get y prime is equal to 2 times e to the 2x times 2 again, right? So I would get 2e to the 2x times 2. Now, if you notice this part right here, this is equal to y, right? So equivalently, I can write y prime, or I'll just write dy by dx is equal to y times 2, or 2y. Now, in this equation, in this form of this equation, you have a derivative and the function in the same equation. And that's what a differential equation is. So a differential equation is an equation which has y and its derivatives all in the same equation. It relates the function itself to its derivatives. And the point of solving a differential equation is to go from this form, this differential form, back to figuring out what y itself is, right? Because looking at this, we only know the relationship between y and its derivative, not y itself, right? So if we want to isolate for y itself, we have to go back here, and that's what's called solving a differential equation. Okay, so there's many different types of differential equations. Let's just go over some characteristics. So let's talk about order. So order of a differential equation. Order of a differential equation is the highest derivative present in the equation. So going back to the equation we have at the top, we had y prime is equal to 2y. So the order of this differential equation is the first order, because the highest derivative in here is y prime, which is the first derivative. If we have y prime, y double prime plus 2y prime plus y is equal to 5, for example, that's the second order differential equation, because the highest derivative in here is the second derivative. Okay, and the next part is an ordinary differential equation versus a partial differential equation. Okay, so ordinary it has normal ordinary derivatives of one or more dependent variables with respect to one independent variable. Okay, so the equations we've seen so far are ordinary differential equations, because we have a derivative right here, and it's concerned with one dependent variable and one independent variable. We could also have, for example, we could have dy by dt plus dx by dt equals, let's say, 5, and that's considered an ordinary differential equation, because the derivatives are ordinary, and even though you have two different dependent variables, you still only have one independent variable. So this is an ordinary equation, ordinary differential equation. Now, a partial differential equation is honestly, you have to know what partial derivatives are to know the distinction between an ordinary versus partial derivative. So maybe you haven't done a course on partial derivatives yet. If you haven't, you can just ignore this section of the video. But partial derivatives, you'll know what I'm talking about. So let's say I have a partial derivative of, let's say I have du by dt, and then plus 2u is equal to 5. So that's a partial differential equation where it has a partial derivative rather than a normal ordinary derivative. Okay, so that's the difference between ordinary and a partial differential equation. More likely than not, you will be dealing with an ordinary case. So this is just, I'm just telling you that there exists partial differential equations also where they have the partial derivative rather than a normal ordinary derivative. And the last characteristic I want to talk about is linearity. Okay, an equation, a differential equation is linear if the dependent variable, let's say y, and its derivatives are of the first degree. Okay, and when I say degree, I mean like the power on it, like y squared, y cubed. So you can't have a y squared, y cubed in a linear differential equation because you're violating this. Y and y prime all have to be of the first order. Sorry, not first order. That's a bad way to put it. Of the first degree. Okay, so let's say I had y double prime plus y prime is equal to 5. Is that a linear equation? Yes, it is, because even though you have a second order derivative, it's still to the power of 1, right? Versus if I had y prime plus 2y squared is equal to 5. This is not linear, okay, because you have a y squared term over here. So don't confuse linearity with order. Okay, so this is a second order differential equation, but it's a linear second order differential equation, okay? This is a first order differential equation, but it's a non-linear first order differential equation. And that's about it for this video. So next video, we're going to actually go into solving simple first order differential equations. And later on, we're going to move up to second and even fourth order. Thank you. Thanks for watching.